Hello, everyone. How are we doing today? All right. Well, welcome. And the plan for this week is to look at chapter 5 in our textbook. And what chapter 5 is kind of the last major component that we need to understand the basics of before we get into working with functions. So, what we're going to be talking about in this chapter are loops and vectorization. Okay. The basic idea behind the relationship of these two ideas is that the main idea is going to have to do with loops, okay? And vectorization, in some sense, is a shortcut to using loops. So there are many formulas where we're going to be working with things, and it's not going to be explicitly necessary for us to use all of the command words and syntax necessary to build a loop sort of explicitly. And so we'll use vectorization to sort of shortcut simple loops. It's eventually how that idea will present itself. But first, we want to talk about what's going on with loops themselves. For loops, there are two primary kinds. There are conditional loops and there are counted loops, right? In MATLAB, the conditional loops are known as while loops due to the command word that is used to start the construct. And counted loops are called for loops for the same reason. Okay, you use the word for as the start of the construct. Sometimes in other programming languages, they have slightly different names for what command words you would use in order to start the construct. In older programming languages, um, you would have the word to do at the beginning and you would have while at the end. Okay. Um, so sometimes if you look at older resources or things having to do with different programming languages, they'll call these do while loops. For is fairly common for counted loops, but there is a little bit of variation here. Okay. But in the vernacular, it is most common to call them either while loops or for loops instead of the more technically correct terms of conditional and counted. I'll use both. All right. We're going to start by looking at conditional loops because that's what we've done more setup work for, given our discussion the last couple classes about logical conditions. that's a code block. All right. So the construct for a while loop is like this. We have while, and on the same line, we have some kind of logical expression. Okay. And while the logical expression is true, then this code block will be executed over and over again. All right. The idea of a loop is that we go down, we hit end, and then we go to the beginning. Okay. And it cycles through many, many times. Okay. Now, there's a few things to know about how MATLAB does this specifically that is a little bit different than some programming languages. Okay. First thing that MATLAB will do is it will check this expression for its veracity before executing the code block. In other programming languages, it is possible for the code block to be executed one time before the condition is checked. Okay, so it seems obvious to us that it would check to see if it's true before it does what's in that code block, but that's not necessarily always the case. All right, it is in MATLAB, so we're okay to use things like this, but we need to expand our knowledge a little bit to make sure that we're not naively doing something that would otherwise go. Okay, so let's look at a very simple example. Clicked away. All right, so we have our scripts here. We're gonna do, we're gonna set, I don't know, I equal to 1. Okay. We're gonna say while 1 is less than 5, display I. Simple enough, right? Okay, this is gonna be very bad, by the way. Okay, I'm going to have to stop this. All right, I'm pressing Control C, which tells MATLAB to stop. Okay, and we have encountered the main danger of using this. The loop that I've just made here is an infinite loop. Okay, it is never possible for this expression to become a false expression. So it's not possible for MATLAB to be able to escape this construct. Okay, so one of the necessary components of a conditional loop is modifying a value with the goal of eventually making the expression in question not true. Okay. Now, this should no longer be an infinite loop. Okay, we see that it does something reasonable here, right? It prints 1, 2, 3, 4. It doesn't do 5 because this is less than, not less than or equal to. Okay. So we'll go back over to the other page here. Okay, so you must have in your code block a modification to the conditions of the expression so that it eventually becomes false. Otherwise, the conditional loop will run forever. Okay, this is a very common mistake for inexperienced programmers to make, is to accidentally generate infinite loops. Okay, um, in our class, the runtime for all of the programs that we write should be very, very small. Okay, unless we're doing something that we know is complicated or requires a lot of data, nothing that we do should have a runtime that exceeds about 10 seconds. Okay, and even 10 seconds is kind of a long time. All right, most of the programs should run effectively instantly for us. Okay, so if you've not had that, something is going wrong. There's redundant calculations or other things that are happening. All right, next up, we'll talk about for loops. Okay, for loops here, we have a different kind of construct. This is an example of a counted loop. And the way that this is set up is that this bit of code here indicates a set number of times that this loop is going to be used. Okay. So we have index equal expression, and it's going to have a set number of iterations. Okay, and also importantly for for loops, the value of index will change for each iterate of the loop. So let's take a look at that. So going back over to MATLAB, get rid of this. Well, I guess we'll leave it there for people who want to copy something down. All right. Okay, so here we have a very simple example of a for loop here. All right. Now, I use the word index in the previous page, but the index doesn't mean anything special. All right. It's just a chosen variable. So the expression that you need is for I equals an expression. All right. It makes I the index for the loop. There's nothing special about the choice I either. I can choose any letter I like. Okay. Or any variable name I like for that matter. And we see that this loop does the same thing that our previous loop did. Okay, once we fixed it. Now, a couple of things are different about what's happening here. Number one, I have a list of values, and this list of values is progressed through by I for each iteration of the loop. Okay? So starts off at 1, then becomes 2, then becomes 3, then becomes 4, and we see that we print this value out each time. Okay? And so when we are programming, one of the things that we're going to do is need to decide what the structure of our program is, what rules we need to follow, what ideas in our algorithm are necessary, and choose an appropriate loop type for that. Okay? Now, there are situations, and we have an example here, where you can sort of fake doing a counted loop using a conditional loop. Right? Okay? The other direction, not so easy. Okay? Trying to make a for loop behave like a conditional loop, much more trickery is involved here. Okay? So it's going to be the case that for loops might for us be more common just because it's kind of a more natural idea. It's like I have this thing I need to do a bunch of times. We're going to set this up to work this way. But part of learning what it is we're doing is involved in setting this up. Now, one of the interesting things about for loops is there isn't anything special about how I build this list here. Okay. So one of the things that I could do, for instance, is decide that instead of counting by one, I want to count by 1/2. Okay. And that is a thing that I'm allowed to do. In fact, I can type in a vector that has numbers that don't have a set list that they expand by. Okay. And there's also nothing that says that these numbers have to be in ascending order or anything like that. Okay, this is just a generic vector. And I go through the vector one element at a time, and the value, and I assumes the value of the next element in the vector for that iteration of the loop. Okay, and it need not even be numerical values, just distinct elements. Questions about this? All right. So let's do an example. Well, let's plan out what it is we want to do first here. All right. One idea that we should be familiar with is the idea of a factorial. Okay. The definition for a factorial is typically given like so, right? Okay. And it's defined to be 1 for n equals 0. Okay, we of course require that n be a non-negative integer. Okay. Now this seems like it should be something that a counted loop ought to be pretty good at, right? Okay, so we can compute the value here. So the code for this is very, very simple. Simple enough that we'll not do anything fancy, like try to code up a or do pseudocode or anything like that. Okay. So if the assumption is that n is supposed to be equal, sorry, we'll do this smarter. So we want to have the user give us the value n for n factorial. Okay, we're going to set n factorial equal to 1 because that's the default case for 0, right? And then we want to count from 1 to n. And the way that we are going to compute n factorial is we are going to take the previous value, we're going to multiply it times the current value of the index, and then assign that value back to n factorial. Okay, so each time we go through the loop, what's going to happen is n factorial is going to be increased. So I'm putting a breakpoint here so that we can see how this works. We'll do my script here. It's going to ask us for a value. I'm going to put in 7 so that there's enough stuff going on that this gets interesting. Okay, so we see n factorial over here is equal to 1. I is equal to 1 right now, and n is equal to 7 because that's the value that we just input. If I hit continue in the debugger here, then I will go down until I hit, I'm right here in the code, I will loop through and then hit this again. Okay, so I'll do one time by stepping and then use continue after that. So step, and then we step back to this first line, because and we hit another breakpoint. So now I is equal to 2. N factorial is still equal to 1 because I did 1 times 1 in the previous step. If I hit continue now, though, n factorial is going to be 2, and I will be 3. We had 1 times 2. Now we're on the next value for the index, which is 3. And next time I'm going to get 3 times 2, which is 6. And then 4 times 6, which is 24. And then 5 times 24, which is 120. Okay, we'll do it a couple more times. And 5,400 is n factorial. Or sorry, 5,040, pardon me. MATLAB has a built-in function that does this as well. Okay, so we can use that to verify our answer. All right, so this is a way that loops can be used. All right, if I have a value that needs to be modified by a repeating process like this, okay, building up all these values. Okay, now, obviously, the factorial is a simple enough thing that there's other ways that this could be accomplished, but this is the kind of repeating process that we might use a loop for. Questions about this? Seems okay? All right. All right. So there's a few things to keep track of when we're working with loops. Make sure that we don't make mistakes while we're programming or things like that. So let's talk a little bit about those. All right, let's work with some best practices. One of the things that you should never do is that if you have a variable that's specified as the index of a for loop, don't modify that value inside of the body, okay? If there is a reason that you need to modify that value somehow, the thing that you would do is choose another variable. Then there are probably ways that you can avoid having to do something like this, but if it's absolutely necessary, the thing that you should do is assign the value to some other variable and then modify the other variable. Okay. Now, if you're going to these lengths, it is probably the case that you could rethink how it is you've got things programmed up to save yourself a little bit of time in calculations, but you should never modify that value. Okay. Another thing under best practices is memory pre-allocation. All right. All right. So MATLAB allows us to do some stuff. Okay, we'll do a variation on this program here. So something I forgot to mention earlier is that like our construct that we had for ifs and stuff, you'll see that the body of a loop is indented. Okay. MATLAB will do this automatically if you're using the command words and stuff, so you don't have to think about this. But there isn't anything that prevents the loop from running if it's not indented. This program will run fine. Okay, but we want to go ahead and make sure that we indent so that our code is as easy to read as possible. Okay, there are other programming languages, notably Python, which you may interact with. The way that Python's loops work is like this. The way that it knows that something is part of a loop structure is the fact that the lines underneath are indented and there's no end statement. Whenever the indentation stops, that's where the loop stops. So the way that things are typed in contextually is how you define the construct. MATLAB uses end statements, which makes things a little bit more clear. All right. It's very frustrating when you're programming in Python sometimes and your tabs become spaces and the interpreter that you're using doesn't recognize the spaces correctly. It's weird. The other thing is that a tab is 4 spaces. Okay. And there are some interpreters that will actually have a tab be different than just tab being a shortcut for 4 spaces, which messes this up. Okay, so you'll notice that, by the way. I've pressed the tab key here in MATLAB, right? Now I'm going to press backspace. 1, 2, 3, 4. Okay. So when you press tab, that's actually what's happening, is it's a shortcut for 4 spaces. Okay. Let's get back to the memory pre-allocation example. All right. Now say I want to make a modification of this program to where instead of having a expression like I have here where the answer that this program returns is the value of n factorial, what if instead I want to keep track of my previous work? I want to know the other values that have been given to me or that I've computed along the way. Okay, so what we can do is we can have n factorial start out as this, but instead of doing this part that I've done here, I can instead say, you know what, I'm going to take the previous answer that I have, okay, and what I want to do is I want to take the last entry in my vector and multiply it by I, and then add that to the end of the list. Okay, so we're going to see what this does. I'm going to get rid of all my variables here. Put another breakpoint here. We'll do up to 5. Okay, so right now, index is equal to 1, n factorial is equal to 1, okay? And I'm about to add to my list here. So I'm going to click continue. Just going to go through one iteration of the loop. All right, and now we see that n factorial is a vector, okay? And if I click continue again, we see that it's still a vector, but it's getting bigger, right? And I'm adding to this the values of n factorial that I'm computing. Okay, so this vector is getting bigger, and part of the reason why it's got this little underline underneath it is that it's going to tell me that this appears to be getting bigger every time the loop iterates, and that I should consider pre-allocating. Okay, now what happens if we don't pre-allocate is that MATLAB will say that this vector that I've created is supposed to live here. Okay? This is the memory, this is the space in memory that is required for me to hold that information, to store that variable. Okay? Now, my computer's doing other stuff. Okay? So my computer might decide, you know what, we're going to use this memory here for other programs. Okay? We're watching some stream in the background while we're doing our work. Maybe we have Spotify turned on or something for background music, whatever it is we're doing. Okay? So we're using up memory to do these other processes. Well, the second step of my program says, you know what, I need twice as much space and memory in order to hold the new vector that I just created because it's bigger, right? But I can't take this memory and add it to the memory that I already have because some other program's already using it, right? So what I have to do instead is give this memory up, copy what I had, and then grab the new memory that I need. And I have to keep doing this every time I go through an iteration of the loop because the loop gets bigger and I don't know where the memory that I'm using is going to stay because the computer's doing other stuff, right? And so this repeated copying process slows the program down. Okay, for large scale problems, this is a nightmare. All right. So when we are working with vectors in loops and things, MATLAB is smart enough to dynamically allocate memory, which is what the picture that I was just drawing, right? But it's slow, okay? In older programming languages, they would just laugh at you and say, you need to know how big your vectors are before you try to do anything, dummy, okay? That's how it worked in the older languages, because memory wasn't fast enough to be able to do those repeated processes and waste the resources and time to do that. So what we should do here is set this up. And we'll use ones. We're doing a row vector. We need this to have n plus 1 entries, right? Because we have to have 0. That makes sense? Okay. And what's interesting about this now is that this can start at another value, right? Should it start at 2 or start at 3? Oh no. Maybe 2? We don't need this line anymore. Okay, so we're having to make several changes here. This will start out as a vector of 1s. Okay, we chose 1s and not 0s. 0s would have been an okay choice, but we chose 1 because we know that the first 2 entries of this thing are going to be equal to 1. So there's no reason to recompute those. Okay, we need to start at index 2, because 2 is going to be the first number that we need to multiply by, right? And we want to multiply the values from 2 to n, right? But this needs to be assigning values to I plus 1, because the first entry of the vector, which is 0 factorial, is 1, right? The second entry of the vector is 1 factorial, which is 1, and the third entry of the vector is 2 factorial. Okay? So this is our first instance where this would be an easier program to write if we started counting at 0 instead of counting at 1. But for MATLAB, all of our indexing starts at 1. Okay, so let's type this out so it's clear. I was going to put an exclamation point at the end of that line, but that doesn't seem to be helpful in this context. Sorry. That's confusing, right? Because we're talking about factorials. Okay, that's why I'm not putting, that's why I'm not doing, we'll use a period. How about that? My touchpad's getting in my way. Okay, so our program needs to do this. All right. This is why we need this I plus 1 in order to get these numbers to be right. I want this to be a 3 the first time I do a calculation. All right. So what we'll see that I'm doing when I run the program is I'm only assigning the next entry in the vector. Everything's going to start out at 1. Then in the third position, because I'm doing I plus 1 and I starts out at 2, I will assign 2 times the previous value. So it's going to be the index value times this. All right. Ready for all this? Okay. So now we're going to input our value. We'll go up to 5. That should be enough to show us that this is working. Okay. This is all ones. We haven't done anything yet. If I hit continue, the third entry should become a 2. We see that it does. Because I was 2. I added 1 to it, which made it 3. So the third entry in this list got changed to 1 times 2. Okay, now I is equal to 3. 3 plus 1 is 4. And that's going to be equal to 3 times 2 because the third entry of this vector, and I get a tooltip that shows me its values, is equal to 2. So I'm going to get 2 times 3. That's going to be 6, and that's going to be plugged into the fourth value. We see that that's what happened. Okay, now I'm going to loop through it again. Okay, n is equal to 4. The previous value is 6. 4 times 6 is 24, and that's going to be placed in the 5th position. And then the last one, we're going to get 120. We'll have to look at that over here because the program's done running. Okay, so this makes sense. I know there's a lot of stuff happening here. Okay, understanding this is part of learning how to use loops effectively. Okay, and this is one of the most important skills to develop as a new programmer is understanding how this information is being indexed and manipulated. Okay, there's understanding the procedure here and being able to communicate these kinds of procedures to the computer is extremely important. Okay, we're very good at organizing information. All right, when we're sitting down working on a math problem, we can draw pictures, we'll write down tables, we'll write down lists, and our mind sequences information for us so that we can sit down and solve a problem, right? Okay. How many of you have had a lot of information that you were trying to track and you did something like, I'm just going to type all of this into a spreadsheet using Excel or Google Docs or something like that, and then have the information all sitting out in front of me so that I can tinker with it and manipulate it? Right? It's not something you do often because it's not fun, but if you need to do it, then that's how you set that up, right? Okay. It's a very common kind of task in programming is being able to understand what your data is and how to move through it, move around it, and manipulate it. Okay. One of the reasons we spent all of that time talking about indexing stuff was to set ourselves up for loops because we have to understand how to think about data and move stuff around and do these kinds of fiddly operations. Okay. And when it's done well, the programs are very short. Okay. That's why we talked through why this looks this way, so that when we're done, our reward could be a program that is very compact. Okay. But we need to make sure that we leave ourselves notes about what it was we did so that the fact that this is so short makes sense. Okay. This is why in the assignment that I admittedly didn't get posted until yesterday afternoon, I mentioned that I want you to leave comments saying, like, the little paragraphs in your code, the collections of each 3 or 4 lines, put in a statement that says this is what this is doing. Okay. For your sake and for mine and for anybody else who happens to read whatever code you write in the future, it gives you direction so that you can figure out, okay, this is what this is supposed to do. And if I can't figure out how it's doing that, then either there's something wrong with me or there's something wrong with the code. Okay. It gives us the ability to solve these problems. All right. Questions about this? All right. MATLAB has a set of special statements that can be used inside of loops. Okay. They are break and continue. All right. And so what happens here with these is that you can use a break command in order to stop a loop at a certain point. Okay. And you can use continue to basically skip to the next iteration of a loop. So if we take a look at this, I don't need to do that way. Sorry. the way that break works is like this. So we have our loop here, okay? The index is supposed to run from 1 to 10, all right? And then I have a condition in the middle that says if it's equal to 5, then break, okay? And what break does is it just skips to the end and stops any other further execution of the loop, okay? Now, most of the time, you shouldn't be using break statements, okay? The best written loops are loops that have well-made logical structures or well-made numerical conditions so that a break condition is never required, okay? But it can be put in there if needed or to stop some kind of process if there's an issue that's detected, okay? But typically we don't want to use these. Now, the other version of this would be a continue statement, okay? And the way that the continue works is that it skips to the next iteration of the loop at that point. So we'll change this to 5. We'll make this equal to 3. So just to be clear about what it is this is doing. So it's going to display the number, then it's going to display the number a second time if the number is not 3. Okay, so what happens is if it hits the continue statement, it skips the rest of the code block in the loop, but will do anything that happens before. Okay, including anything that happens right before the statement. Make sense? All right. All right. So the big next idea in the chapter is talking about something called vectorization. Okay. Now, vectorization is very powerful, and it's something that we've used a little bit of, but we haven't really talked a ton about. Okay, sorry, hold on a second. I'm gonna back up a little bit. Sorry about that. We will talk about vectorization before we run out of time today, but there's something else, an important idea that I forgot to mention. Okay. When it comes to our control constructs in MATLAB, we can use them together, okay? We can put while loops inside of for loops. We can put for loops inside of other for loops. Okay. We can mix and match as necessary. There's nothing stopping us from doing any of these things. All right. And so a lot of the power of using loops is the fact that we have the ability to combine these things. Okay, so for instance, say I want to make the following matrix. Okay, I'm going to make a matrix. The matrix is going to be named capital A. And the way that the matrix is going to be set up is that each entry is going to be the product of its row and column indices. Okay, so if I have, say, a 3 by 3 matrix, all right, this is the first row, first column, first row, second column, first row, third column. Second row, first column, third row, first column, second row, second, third row, second, second row, third row, third column. Okay, this is a matrix that I can make. So if we go back over to MATLAB here, okay, so we're inputting in for the dimensions of an n by n matrix. All right. We're going to make a matrix of zeros. Okay. And what we want to do is for I equals 1 to n, and for j equals 1 to n. The fact that they're both 1 to n here doesn't matter. Okay. We could make them different indices and it'd be fine. We'll do an example like that here in a second. What I want to do is I want to make the entry of ij equal to I times j. Should be a thing that I'm allowed to do, right? Display a. And we get what we should have gotten, right? Matches this. And so what happened here was that we went through the first loop. I is equal to 1 this whole time. And then we iterate through j. So we get 1 and then 2 and then 3. And then I increases to 2. And then we do 1 and 2 and 3. And then I increases to 3. And then we go 1 and 2 and 3. So if we were to step through this, oops. Hold on, stop. I messed up. Sorry about that. Okay, so now we haven't assigned yet our first entry. We'll see that I and j are both equal to 1. I hit continue, and the first element in the first row has been assigned. I can type in A if I want to look at what A is. I can hit continue. We see that the second element has been assigned, and then the third. If we look at A again, we see that the first row is done. And then if I click continue 3 times, 1, 2, 3, that's the second row. And I'll do it 2 more times. Hasn't done the last entry yet. We'll continue, and then the program's finished. So A is now equal to this value. Okay, so we can put these things together, right? Another thing that we could do would be to say, that we want to do this for an m by n matrix. So we'll do, I don't know, 4 by 3. And I forgot to change this line, so it didn't work right. Okay, so there was these expressions have nothing to do with each other in terms of the way that they're dimensioned. Sorry, this should say m by n. So the most correct version of this looks like that. All right, so we can put things in here. All right, so one of the places where a break statement might be appropriate is say you have some process that's going through a large number of iterations, and after a certain number of iterations, you decide that the program you want to cut it off. Okay, so we had a while ago our factorial value. Okay, and then for I equals 1 to n, we'll do sorry, I didn't think about this very well. This is more like an if. This is an if break, not a while break. Okay, all right. We'll revisit that idea. Anyway, there are some loops that you would set up to where you have while loops and counted loops working together, but the example that I want to do would take a little bit too long to explain in our remaining time. So we'll set that aside for now. Okay, One last idea that I want to introduce, and then we'll go into more detail next class, is the idea of vectorization. Okay? There are loops that can be handled in a way that does not require an explicit set of a writing out of a loop. Okay? We've done many times the, I just had it typed in, so we'll take advantage of it. Idea for n factorial here, right? If we're doing vectorization, the idea is that for simple loops, I can just use mathematical expressions to replace what it would be that the loop was up to. Okay? So I could do n factorial by just saying that I want to take the product of this vector. That's the answer. Okay? So what I do is I make a vector that is relevant to my problem. Okay? And then I use a MATLAB command or whatever that is a vectorized operation. The prod command takes the product of all of the elements in the vector that has been defined. So this is the list of numbers from 1 to n, all the integers. Okay, we count down so that it's convenient. I could have also counted up, I suppose, to make it less oblique what's happening here. I'm just used to thinking about the vector, and for factorials going the other direction. But same deal. Okay, so we can and often will choose to, because our code is easier to read, if vectorization applies, to use vectorization. Okay, because we get things that look a lot more like mathematical formulas in our code written out, taking advantage of this. And we can do calculations to entire large vectors at a time. Okay. The other aspect of vectorization is that if I have an entire list of values that I need to do some mathematical process to, I can just do it to the entire vector at once instead of writing a loop that goes through and then tweaks into each of those values individually. Right? So we can take advantage of these sorts of things. So that's the direction that we're going. We have plenty more to do there. The most important thing in this chapter of the text for you to go through and read is there's a lot of kind of longer examples that I'm not going over in detail because it's not an effective use of class time. Not that it's not important for you to read through and figure out how things are put together. Does that make sense? Okay. I can tell you stuff that's not in the textbook and show demonstrations of kind of corner case type things. That's what I'm going to be focusing on, by the way. But you should definitely look through and read through these things, and we'll continue on next time working through more of that. Sound good? All right. I will see you next time.